Today we are talking about natural log and E, which is section 5 of unit 8, starting with what E is. E is an irrational number, think like pi, with an approximate value of 2.71828, and then it continues on forever. E often occurs as the base of exponential and log functions that describe real-world scenarios. I don't remember how much of this blank I left in your note packet.
It's all filled out.
Oh, okay. All right. The base E of an exponential function are called a natural base exponential functions. And did I? Oh, I did. Look at that. There's our example. F of x is equal to e to the power of x. We have base E logarithmic functions. Logarithmic functions with base E are called natural logs. For example, we have f of x is equal to log base E of x. Yeah.
Wasn't a natural logarithm log base 10 of x?
That's a common log. Common logs are base 10. Natural logs are base E, but we don't usually write it like this. It's usually written as ln of x. So this would be the log base E, but we write it as ln for natural log.
Logarithm.
So that is log base E of x is equal to the natural log of x. It's the same thing. So in example 1, we're converting between forms. We're going to write each equation in logarithmic form. So let's start slow. We have log base E of the answer, 24, is equal to the exponent x. But we don't write natural log like this. We write it as ln of 24 is equal to x. You don't really need to do the first step, no. I'm just taking the time to step by step to make sure that we know where this is coming from. So then in part B, we would have log base E of the answer, x, is equal to the exponent, 9. So then that would be the natural log of x is equal to 9. So then for C, what are we looking at?
Log base E of 72 equals x plus 5.
All right. Log base E of 72 is equal to x plus 5. And then how would we write it in the abbreviated form?
ln of 72. This isn't terrible. No, just reformat it.
Yep. Example 2, converting between forms. Write each equation in exponential form. So we have the natural log of x is equal to 58. So that means that the base of our exponent is what? E. The exponent is 58 equals x. And this is, again, where can we solve this now? Yes. We aren't going to. Right now we are just converting. So B would be base of what? E to the power of x is equal to 6. So then C, we have base E again to the power of 32 is equal to x minus 9. Yep, that's all we're doing on these ones.
We did it.
We're just leaving it like that.
And that's the whole lesson. One more.
There's a little more, but it's nothing we haven't done. It's just now we're doing it with natural log. So example 3, condense and expand. Condense each expression into a single logarithm. So when we have addition between logs, what do we do with what's inside? Multiply it. So then we have the natural log of 3 times 16. So then we have the natural log of what? 48. And that's our single logarithm. Now we're going to do B. We have subtraction, but what do we have to take care of first? This multiplication here. What does this do for us? It becomes an exponent. So we have the natural log of 63 minus the natural log of 3 to the power of 2, which is 9, yes. So then the natural log of 63 minus the natural log of 3 to the power of 2 of 9, or rather 9 is what I'm saying. What does that subtraction do for us?
It divides it.
We divide it. So we have the natural log of 63 divided by 3 to the power of 2, which is 9, which is equal to 7. So we have the natural log of 7. No, you cannot switch the L and N to be an H.
It looks like an H, he's right.
But it is not.
Or if you draw like an upside down capital L, that would be EX.
Well, that's used when you're using E as an exponent, unless you're talking about the E to the power of X. Yeah. So example 4, again, condense and expand. This time we have some condensed logarithms that we're going to expand out so that we have only a single value inside of our parentheses. So what can we separate here? 5 and x. Because these are being multiplied, how can we separate them? With addition. So we have the natural log of what? 5 plus the natural log of x. That's it for that one. Part B, there's a little more here. What's the very first thing we can do? Put the 2 out front with multiplication. So 2 times the natural log of a to the power of 3 over b. Oh, that's a 6. B. Okay. Now what can we do? We can do subtraction. So we have 2 times the natural log of a to the power of 3 minus the natural log of b. Oh, yep, I forgot the 2. Okay. So we did have this 2 that we have to multiply by both. Is this enough?
No.
No. What can we still do?
You can put the 3 in.
Yep. We need to move that exponent.
6 L.
So we have 2 times 3 times the natural log of a minus 2 times the natural log of b. So then we have 6 times the natural log of a minus 2 times the natural log of b. And that is where we stop. There's nothing else we can simplify here. All right. That is all of our rearranging stuff.
Now we're solving.
Now we're going to do some solving. So, steps to solve equations with natural log or E. 1, you're going to isolate the log. 2, use the natural log. And then 3, expand if necessary. And then 4, solve. That's kind of vague, but it's the same steps that we've been doing, so it shouldn't be too bad here. So we have the natural log of 8x is equal to 2. So if we BAP the log, we have e to the power of what? 2 is equal to 8x. E to the power of 2 is something that we can solve easily because there's a button for it on the calculator. I'm not going to type it in just yet because what are we going to have to do with this 8? Divide it. So in the calculator, I'm going to type in parentheses e to the power of 2 and then divide by 8. And I will, yep, switch so that we can all see what we're looking at here. Okay. So on the calculator, there's kind of 2 options for how you can do this. One of them is a little less work than the other. So we actually have an e to the power of x right here that some of you already found. So you'd hit second and then the natural log button. And that gives us e up there. The other option is we actually have the letter e by itself over here above the divided sign. So you can type that and then use the caret key. I wouldn't use that myself. I would just use the e to the power of x button. So the big EE is for scientific notation. So instead of typing times 10 to the power of, you would just do EE, and then you'd put the power. All right, let's go back to solving what we have here. So we have in parentheses, second natural log, e to the power of 2. Make sure you arrow out of the exponent. Close the parentheses, divided by 8. That gives me 0.92. So x is approximately 0.92. Okay. I'm probably not going to put my calculator back on the screen. I'm just going to work over here. So on this one, we have the natural log of x minus the natural log of 9 is equal to 7. What can we do with this stuff right here? Divide it. So I have the natural log of x divided by 9 is equal to 7. Now we're going to back the log. So we have what base? E to the power of 7 is equal to x divided by 9. How do we get x by itself? Multiply both sides by 9. So then in the calculator, we have 9 times, and I'm going to use parentheses here, although you probably don't really need to. Second natural log, e to the power of 7, and that gives me 9,869.7, approximately. We've got 2 more examples here. This time, we have our exponential form already, and we're trying to solve for the exponent. So what can we do to solve for that exponent? We're going to put it into logarithmic form. So we have base e, which means what kind of log do we have? Yeah, it's a natural log. So we have the natural log of 57 equals x. So on the calculator, we're going to press the natural log button, which was the same one we were using for e to the power of x, but you don't have to press second this time. So I have the natural log of 57, which gives me x is approximately 4.04. All right, last example here. Yeah, I usually do. Just a good habit to be in. For D, we have e to the power of y plus 3 minus 6 is equal to 24. We need to isolate the exponent first. So we're going to add 6 to both sides. So I have e to the power of y plus 3 is equal to 30. Now what do we need to do?
Log base e of 30 equals
Map the log. So natural log of, 30 is equal to y plus 3. And then from here, we need to get y by itself. So what do we need to do? Subtract 3 from each side. So in the calculator, we're going to type the natural log of 30, and then we're going to subtract 3 from it. And I'm actually going to type that all in one line. Just make sure you close the parentheses. So I have y is approximately 0.40, or just 0.4. 401, technically.